Okay, this is going to be a quick video to introduce you to a, a concept, at the end of which you're going to need some software on your TI graphing calculator, and I'll talk about that very quickly at the end of the video. So first of all, if you're in my class, why don't you grab your textbook, go ahead and do exercise 5 in section 6.1. It's a quick practice of the rectangular approximations that we did in the last video, in video 2. Want to talk very quickly about these rectangular approximations. We did this middle rectangular approximation where we assumed that the height of our rectangle is going to be smack in the middle of the interval. Now, the problem here, of course, is it makes it more complicated. We had to take each interval and then we had to divide the width by 2 and then add those to get this list of midpoints. There's a couple ways that are easier, but they come with their own drawbacks. So the first is the left rectangular approximation method. RAM stands for rectangular approximation method. And we can, as you can see, I've pre-drawn here, we can make our rectangles have their height on the left side of the rectangle right on the curve. So in the example that we did previously, that means that this height right here would just be the left side of the interval squared. The drawback, of course, is that then you can see that our rectangle is a little bit below the curve because it's an increasing curve. We're losing a little bit of area every single time we do a calculation. Now, the other possibility, of course, is the right rectangular approximation where the height of our rectangle is just the right side of our interval squared. So remember, our curve was t squared. Again, disadvantage, we're counting a little bit of excess material every single time, which means that our approximation is going to be a little over. The advantage of the midpoint, of course, is that we had a little bit of over to the left here. We had a little bit of under to the right because we have an increasing curve. And those tend to balance each other out a little bit at the expense of a more complicated calculation. So those are the three methods of rectangular approximation: middle or midpoint rectangular approximation method, left rectangular approximation method, right rectangular approximation method. And what you are going to need for the next part of this is a Riemann sum app on your TI calculator. I'm going to show you how to do this on a TI 8384 series operating system. If you go to calcblog.com software, there is in fact a Riemann sum program already built, already written for you. If you search on the internet for your particular calculator, I'm sure there are lots of them. If you are in my class, I'll be just loading this right into your calculator in class. And if not, in order to load the software, you will need free software from Texas Instruments called TI Connect. Once you have the TI Connect on your computer and you have loaded a Riemann sum app, just make sure that it can handle doing all three midpoint, left, and right rectangular approximations. All right, I'll leave you to get that software, and we'll come back with video number 4, where we'll talk about using the calculator and why it turns out to not matter which of these three we use. All right, thanks for watching.